going to go over parts B of 2023 Fermat contest. Also, the solutions in the video are not official, so please correct us if you see any errors. Question 11. At the start of this month, Mads and Sala each had 100 coins. For Mads, its assist was 25 more coins than she had at the start of last month. For Sala, this was 20% less coins than he had at the start of last month. The total number of coins that they had at the start of last month was. Okay, so the number of coins Mads has at the start of last month be M, as the number of coins Sala had at the start of last month be S. And M times 125 over 100 gives us 100, therefore M equals to 80. And S times 80 over 100 equals 100, so S should equal to 125, and 125 plus 80 equals 205, which is E. Number 12. A rectangle has a length of 8 cm and a width of pi cm. A semicircle has the same area as a rectangle. What's the radius of the semicircle? So the area of the rectangle would be 8 pi. And the area formula for a semicircle would be 1/2 of a circle, which would be 1/2 of pi r squared. And we can cancel the pi. Therefore, we're left with 16 equals to r squared. And this gives us 4 as r. Number 13. If a bracket x plus 2 plus b bracket x plus 2 equals to 60, and a plus b is 12, then x equals to... Okay, so if we take out x plus 2 from both terms on the left side, then we're left with x plus 2 bracket a plus b equals to 60. And because a plus b is 12, therefore x plus 2 must be 60 over 12, which is 5, and this leaves us with x equals to 3. Option A. 14. A line with a slope of 2 and a line with a slope of -4 each have a y-intercept of 6. The distance between the x-intercept of this lines is. Okay, so let's the line with a slope of 2 be line A, line 1, and the line with a slope of -4 be line 2. And the equation for line 1 would be y equals to 2x plus 6, and for line 2 would be y equals to -4x plus 6. So if we want to get the x-intercept, we need to set y to 0. Therefore, the x-intercept for line 1 would be 0 equals to 2x plus 6, and x equals -3. And the x-intercept for line 2 would be -6 over -4 equals to x, and this gives us 3 over 2. And if we use 3 over 2 minus -3, we get 9 over 2, so E. Number 15. A sequence has 101 terms, each of which is a positive integer. If a term n is even, then the next term should equal to 1/2 n plus 1. If a term n is odd, then the next term equals to 1/2 bracket n plus 1. For example, if the first term is 7, then the second term is 4, and the third one is 3. If the first term is 16, then what's the 101st term? Okay, so if the first term is 16, the second one should be half of 16 plus 1, which is 9. And the third term would be 5. And the fourth one would be 5 plus 1, 6 over 2, 3. And 1/2 of 3 plus 1 gives us 2. And 2 over 2 plus 1 would also be 2. And just keep going. And since after the first 2, we also get a second 2. Therefore, all the rest of the terms should be 2. And the answer should be B. Number 16. 25 cards are randomly arranged in a grid as shown. 5 of these cards have a 0 on one side and 1 on the other side. The remaining 20 cards either have a 0 on both sides or 1 on both sides. Lorden chooses one row or one column and flip over each of the 5 cards inside row or column, leaving the rest of the card untouched. After the operation, Lorden determines the ratio of zeros to 1 facing upwards. No matter which row or column Lauren chooses, it's not possible for the ratio of 0 to 1 be. Okay, so let's first get initial ratio of 0 to 1. So let's count the zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it should be 14 zeros to 25 minus 14, which is 11 ones. So if we want to get answer A, we would have two fewer zeros and 2 more ones. And you can get that by flipping over this row. And if we want to get answer B, which is 10 zeros to 15 ones, then we need 4 less zeros and 4 more ones, and we can do that by flipping over this row. And if we want to get option C, we would need to have 5 less zeros and 5 more ones, which in the other word means one row has to be all 1 or all 0. And so it's not such a row in this grid, therefore C is impossible to get. Number 17 is a positive divisor of 6 are 1, 2, 3, 6. The sum of the positive divisor of 1, 1, 8, 4 is. Okay, so the most convenient way to find the answer probably just find all the divisor of 1, 1, 8, 4, and we can do that by doing short division. So 1, 1, 8, 4 divided by 2 gives us 592, and 592 divided by 2 is 296. 296 divided by 2. 148. 148 divided by 2, 74. 74 divided by 2, 37. Since 37 is a prime number, so this should be the end of the short division. So the divisor should be 1184 plus 592 plus 296 plus 148 plus 74 plus 37 plus 2 to the power of 0, 2 to the power of 1, all the way to 2 to the power of 5. And this gives us 2394A. Number 18. A robotic grasshopper jumps 1 centimeter to the east and then 2 centimeters to the north and 3 centimeters to the west, then 4 centimeters to the south. After each 4 jumps, the grasshopper restarts the sequence. After a total of n jumps, the position of the grasshopper is 162 centimeters to the west and 158 centimeters to the south of its original position. The sum of the square of the digit of n is okay. So if this is the initial position of the grasshopper, then after the first sequence, it should be 1 centimeter to the east, 2 centimeters to the north, 3 centimeters to the west, and then 4 centimeters to the south. And the end position would be 2 centimeters to the west and 2 centimeters to the south from the initial position. And therefore, if the last sequence of jumps is complete, then the grasshopper should be 162 centimeters to the west and 162 centimeters to the south. However, now we only have 158 centimeters to the south, which is 4 centimeters from 162. And 4 matches the 4 jump to the south in the sequence. Therefore, we know that the last step in the sequence is not complete. In the other word, the grasshopper should stop here. So let's just pretend that the last sequence is completed, and this would give us 162 over 4 sequences, which is, over 2, which gives us 81. However, because the last step is not completed, therefore the total number of jumps should be 81 times 4, because there are 4 jumps in one sequence, minus 1. And this would give us 81 times 4 equals to 324 minus 1, so 323. And 3 square plus 2 square plus 3 square would be 22. So the answer is A. Okay. Number 19. If x and y are integer with 2x plus 8y equals 26, a possible value of x minus y is. Alright, so if we take out 2 for all the terms in the equation, we'll get x squared plus 4y equals to 13. And if we plug in different numbers, start with 1 and -1, since x has a square, so 1 and -1 should have the same y, and this would be 3. However, 2 or -4 is not one of the options, so let's just keep going. 2 and -2, and we wouldn't get a y as an integer. 3 and -3 would be 1, and there's no such a solution. And 4, -4 doesn't work. 5, -5 would be -3. However, 5 minus -3 would be 8, not -8. So we still need to do more numbers. 6 and -6 would have no solution. 7, -7 would be 9, and this would give us 16, but we don't have 16 as one of the options, so it doesn't work. And 8, -8, no solution. 9, -9, and 17. And if we use 9 minus 17, we will get -8. So the answer would be A. Question 20. If n is a positive integer, the symbol n factorial represents the product of the integer from 1 to n inclusive. For example, 5 factorial equals to 1 times 2, 1 times 3, times 4, times 5, or 5 factorial equals to 120, which ends with exactly 1 0. For how many integer m with 1 smaller or equal to m and m smaller or equal to 30? It is possible to find a value of n that n factorial ends with exactly m zeros. If we prime factorize 5 factorial, we'll get 5 factorial equals 1 times 2 to the power of 3 times 3 times 5. And because we have at least a pair of 2 and 5, therefore we would have 1 0 at the end. And since we know that we need at least one pair of 2 and 5 to get an extra 0, therefore, and we know that even number is always more than, we always have more even numbers than multiple of 5. Therefore, we can just count the number of 5 in a factorial to determine how many zeros are at the end. So, if we time it by 10, we would get 2 zeros, and 15, 3, 20, 4, and 25. Because 25 equals to 5 square, which means we have 2 5. So we would skip 5 0 and just get 6 0. And same with 50, which is 2 times 5 square, 2 times 25. So we would skip 11 and just get 12 zeros. And we just keep going like that, and we get 28 times 120, and and we get times 120, it's 28 zeros, and times 125 would be 31 zeros. So we would get 30 minus 30 over 5 since we get like 5 squared for every 5 numbers. But we need to plus 1 because the first 5 number would be 1 to 5, and 5 is not a square of 5. So we need to plus 1. So we got 30 minus 6 plus 1, which gives us 24.